Hey everyone, welcome back to my another tutorial, and this is the continuation from my previous tutorial where I showed you how to prepare custom data for your you only look once with 3 object detection training. So in this tutorial, finally I will show you how to train that model. But first, I must mention that this code I will show you in this tutorial is originally not mine. I was inspired by, I don't know how to pronounce it, QQWWEE, and he wrote an amazing code which I used to train my custom Keras model. And actually I want to say why I should write everything by myself from scratch if there is already written, and it's quite the same as YOLO and it's working, so I will just use it and I'll make it simpler to use for you, and I actually will show you how to use everything. And actually I already started in my previous tutorial. So at first, to make this code more efficient, I made a few modifications for it. So originally this code used a pill library to load images for detection, so actually obviously I'll replace it to OpenCV because it's more efficient and faster. And this code originally used an external font for drawing text on detected images. Actually I did the same, replaced it with OpenCV, and I wrote my own detection script for one image detection and real-time screen detection. I'll show you a quick start guide how to do everything. So you don't need to copy his code. I actually added everything to my own GitHub page, so here it is. I'll of course post the link to my text version tutorial and this subscription under my video, and keep following it. But before you do everything further, make sure that you have done everything here in this tutorial where we were preparing our dataset for further training. So I already posted this to GitHub, and you can read this tutorial and you'll find everything you need, and there shouldn't be any questions and everything should work just fine for you. And let's continue on it. And okay, so at first what we should do is we should download the weights. So actually what you should do, I already post on my webpage the link how you should download the weights. So if I'll open this console, I'll write widget and to get YOLO weights. Okay, I'll just can press enter and it keeps downloading, but actually I already have it, so I don't need it. I'll just remove this. I have it here, so you should do the same, move everything here. Next, what you should do when we have our weights, we should convert them to a Keras model. So also we open the console here, and there is a Python script convert.py called, and I can open it for you, convert.py. And keep in mind that if you don't have GPU, replace this with -1 or simply remove this line. I have few GPUs, so I'm just replacing it to use one of my GPUs because you don't need more. And actually you just write it to convert YOLO weights. Okay, I think yes, I can press enter and let's see what happens. Of course, your weights should be in this folder, and right now I'll replace this YOLO weights file, and it should update in a moment. As you can see, it's right now updating. Before training, I will tell you that there's 2 methods to train. As you can see, there's 2 files, train.py and train bottleneck.py. So at first, what is bottleneck? So this method is if you don't have a GPU but you have a lot of RAM and a lot of HDD space, because this model kinda converts full model and puts it on the RAM and so on, and freezes it, not to train full of it, but train only the last layers. And actually, with this method, you can do a training on CPU, but keep in mind, you shouldn't have a lot of examples of images because, well, that's obvious. You won't have enough RAM or HDD space. Well, actually, I trained it on few hundred images, I think 600, and when I tried more, I think I tried with few thousands and I hit the memory limit and so on. So it's possible only with low amount of images. And there is another method. It's actually as we originally see. So that's mostly used for GPU. So I'll open it. It's very similar to train bottleneck. And what you need to do here, so if you want to train your model, as you can see, I've copied these two files from my last tutorial where we generated them with my custom scripts. And as you can see, there is links to my images, and here is my used classes. Okay, I just copy the txt names here. As you can see, here will be my log directory. So here will be saved my trained model and checkpoints, and here is my classes. And I originally will load YOLO original actors, and if you don't know what it means, just leave it as it is and don't do anything. So as you can see here, it's possible to train even a tiny model, but I haven't tried it because, well, I don't want to do that, and I will use original model. So as you can see here, if you're training for first time, leave it as it is. Otherwise, if you were training on CPU and you didn't have time to finish the training, you can put here the checkpoint name and so on, and it will continue training from where you stopped. And next, here's a batch size of 32 and epochs of training. So leave it as it is. Well, if you want to do a more accurate model, you can increase this epochs count and this one. And if you, for example, training from checkpoint, you might skip full this part and continue on this part and change the epochs and so on. Well, actually, you should try it by yourself. And as you can see, there's two parts of training. It's stage 1 when it finishes training of 50 echoes, and its final model where it continues to train from 50 to 100. And keep in mind that, as you can see here, I changed the batch size to 8 because I tried to train model also with batch size of 32, but my GPU couldn't handle the memory it needs because, well, actually I have 1080 Ti GeForce, and yeah, it was not enough. So I simply reduced this to 8, and actually everything was quite fine. So you should do the same. On the train bottleneck, it's a little bit different here, and everything is same here. I logs it. As you can see, I didn't use 000 folder here in logs. So I could test both of these models for my detections, how it perform. So I can say that bottleneck model is less accurate than train model, but yeah, that's because here we train only the last layers, there we train on full layers, all layers I mean. So here is also batch size of 32, but here it generates a bottleneck file. So more images you have, bigger the file will be. And actually with few hundred, for example with 800 images, this file might take more than 10 gigabytes, and more images, more size it requires. And keep in mind, it might be not enough of RAM for you. Well, actually, this is what it requires. This is the cost of YOLO. But will receive a performance. So actually, what I can do, I can simply run one of them, and let's see what I have. 0 GPU. Okay, it should be fine, and I can run it, and you'll see that it will start training. But I actually won't do full training because I already did this before. I only wanted to show it for you. So as it will start, I will close it, and we'll continue on showing you how the detection works. So as you can see, it started and everything works fine. It keeps training, as you can see, and it took for me, I don't know, 2 hours and a half to fully train it on my GeForce. But I think my model is not that accurate as I would like it to be, so maybe I'll train it again, because here I just did this for testing purposes, if it works or not. But yeah, it was working. And now let's continue on testing the trainer model. I will close this, and yeah, I close this. Here is my model. Here is trainer final model, which I think I trained on bottleneck, and this model is which I trained with not using a bottleneck. So I would use this final model. So okay, let's come back. And where is my image detect? Here I created this script. Here, as you can see, I will use CPU here, and I'm using here not bottleneck model here, and I wrote everything here, and of course I'll put this on GitHub so you can just download it and use it. Of course, you can use everything on original YOLO model. You don't need to train if you want to just try it out and so on. So let's try to detect hydrant JPEG image. It's simply a one image, and I will run it. It might be laggy because I'm using on CPU. I'm recording also on CPU. Let's see if it will be laggy. I will just leave it as it is, and it finished. As you can see, we have a fire hydrant because I trained this custom model just on 4 classes. It's bus, car, fire hydrant, and traffic lights. So that's amazing. And one more example, I wrote my real-time detection script. If you were following me for quite some time, you should remember that I did a lot of experience on object detection API, which I also trained, and I wrote a multiprocessing grab screen script here because it's faster, and no one else did that, just I did. I don't know how didn't thought about that, but right now it's on all the internet and people start using my scripts. So whatever, and I want to say that let's test this out. I'm grabbing a screen here and just showing it here, and yeah, we can test it out. Of course, I might reduce the size of it because of course you won't see anything if I'll leave it as it is. And yeah, I'll use on GPU, and of course you'll see the performance, how fast it is really detecting. And yeah, I think I can run it. Real-time detect. I'll minimize this window. We don't need it large. And here will be my browser. I'll also a little bit change the size of it. And here comes my screen, which I see. Okay, it sees 20 frames per second, 22 frames per second. I can minimize it. So now let's go to Google and grab, fire hydrant, images. Okay, what we have here? Yeah, as you can see, it detects the fire hydrants. It's not the perfect because I used only 100 images to train it, or I don't know, maybe 200. Well, it's not a lot, but as you can see, our performance is quite nice. While it's detecting, we receive more than 20 frames per second. Well, yeah, that's quite nice. Okay, car, we can just check if it detects cars. For me, yeah, it works and it detects cars quite well. Well, even this supercar. Okay, and one more, traffic lights, I think. Traffic light. Yeah, traffic light. I need real traffic lights, not the drawn. Traffic light, traffic light, traffic light. Yeah, it quite works, but I used only 100 images to detect these traffic lights because I don't know, the dataset was corrupted or something like that. I couldn't use all of them. I was receiving some kind of error, so I should retrain it on bigger dataset, but not this time. I'm not focused on these traffic lights. As you know, I am doing this only for testing purposes and to show you that custom object detection works. Moreover, if you remember my pile lessons, I was doing some pile lessons. I was doing my object detection API. We don't need this anymore. I was doing this one and I wrote everything how to use object detection API and how to create a dataset, how to label it, and so on. And okay, let's see where I have it. I don't remember. It's already working. It's not a custom. Okay, let's move on. It's also not a custom. Here I started doing a custom. So I used label pictures, and if you want to use the same, I have uploaded it somewhere. It should be on this page or another page, I don't know. Here it is, GitHub, this possibly mine. Yeah, so here it is the images, and here is train. Okay, there is some kind of error, doesn't matter. And you can download all these images with XML, and you can use the same script as I used to convert them. This one. And you don't need to, you just go to the bottom and you use walk to YOLO v3, sorry, py.script. And you will receive everything the same. So actually, you just use the script to label images, as you can see, find on my tutorial page, and actually you can convert them to YOLO and just train them and then detect images. Actually, you don't need object detection API, so it will be much easier for you and me, and we'll see. Next tutorial, I will train a Counter-Strike Go detection for enemies, and yeah, we'll see the performance. Of course, I'll try to write a head shooting bot and so on, and maybe later I'll write again a new script for captcha, breaking, and so on. So we won't need to use object detection API. So I think that's it for this tutorial. My code is working. I'll load this to GitHub repository. You can download it after this tutorial is posted. Maybe it will take me a few hours to write everything, to check everything, if everything is in places and so on. And yeah, you can use it. And wait for next tutorial where I write a Counter-Strike Go shooting heads bot. That's it. Thank you all for watching. I hope this tutorial was useful for you, and Of course, you'll use it for object detection. So thank you all for watching. Goodbye, subscribe my channel and like this video, and see you in our next tutorial. See ya!